is up, my algebros and algebras? Welcome to another wonderful day of math class. Our quote for today is a fabulous Yoda quote saying, "No, try not. Do or do not." There is no try. Basically, what that means is if you set out to do something, go ahead and do it. Don't pretend to yourself like you're trying when you're actually not. So today's lesson is a little bit of a detour from our systems of inequalities. We'll be talking about the distance between 2 points today as a kind of a review of a couple of things and also Pythagorean theorem while we're at it. So let's go ahead and get started. So if you remember the Pythagorean theorem, that's referring to right triangles, right? 90 degrees only. And if I classified the side lengths, my short side would be A, my medium side would be B, and my long side would be C. A and B are interchangeable, and when you plug them into Pythagoras' theorem, right, A squared plus B squared equals C squared, we can find the length for an unknown side. So to do that, let's just give an example. I'm going to pick the sides 3 and 4 for A and B respectively. So 3 squared, right? A squared over here would be 9, and B squared over here would be 16. That's going to equal whatever C squared is, right? So 9 plus 16 is 25, and that is equal to C squared, right? And I don't want to know C squared, I just want to know C. So I'm going to go ahead and square root both sides. And when I do that, I get 2 possible answers whenever I square root. I get 5 times 5 and negative 5 times negative 5. Obviously, when we are dealing with a distance, right, a physical space in reality, it cannot possibly be negative, right? You can't have negative distance. So 5 is our correct answer, and the other side length would be 5. Another way to do this, or to solve for a different point, would be, let's say we already have our C side length, and let's say that's 13. So we have a side length of 13, a B side length of 4, and it's probably not going to work out very pretty, but let's try it anyways. So we don't know what A squared is, so we're going to leave it as A squared. Our B squared value is 4, so that's going to be 16. 4 squared is 16. And our C squared value is 13 squared, which is 169. All right, to solve algebraically, we would subtract 16 from both sides. We get A squared equals 153, which to the best of my knowledge is not a perfect square. So our A side length is actually the square root of 153. Whatever number that is, Mr. Carter doesn't really know because it's not in his brain. All right, why would we use this? So one way we would use this is to talk about the distance between 2 points like I had talked about earlier. And it may not look like it, but the distance between 2 points is represented by a triangle. So we can go ahead and draw this triangle right here, much like you would draw a slope triangle if you were trying to figure out slope, right? You make a 90-degree right triangle with the 2 points. That is going to give you a right triangle that we can then use for Pythagoras' theorem. So if we have A here and B here and C here, right, we can plug it into the formula and calculate for C. Usually, we can figure out A and B from the 2 points, right? The A value is going to be the change in the x, so how far it goes from one point to the next. And the B value is going to be the change in the y, or how far it goes from one y value to the next. So let's go ahead and practice that. If I have the points 1, 3, and negative 2, 5, if you could picture those on a graph, right, you could draw the triangle, and I believe that you could plug that in. But we're going to do that with points first. So we would have the change in the x, which would be 1 minus negative 2, right? And minus and negative is the same thing as adding, so we have a 3 over there. The other distance is going to be 2, right? The distance between 3 and 5 is 2. 3 minus 5 minus 3 is 2. So we have 3 squared plus 2 squared equals c squared. If you can picture, we calculated the horizontal distance as 3 and the vertical distance as 2. If you were doing this graphically, the slope would have a -2. Sorry, 3 over -2, right? But it doesn't matter when we're working with distance because the negatives would cancel out. So 3 squared plus 2 squared, 9 plus 4 is 13. And so our distance between these 2 points would be the square root of 13. All right, let's see if you guys can do it on your own. So I'm going to give you a chance to find the distance between the point -3, 1 and 2, 7. I will give you 30 seconds. Please pause the video if you don't want to know the answers. I'm going to dunk the basketball. Awesome. Okay, let's get started. So the distance between -3 and 2, right? We would do -3 minus 2, which would give us a -5. Once again, distance doesn't really get negative, so it's really the distance from 0. So -5 would represent a +5 distance in the horizontal variance of our triangle. The y change would be 1 minus 7 or 7 minus 1. Either way, we should get a difference of 6, right? 1 to 7 is a change of 6. 6 would be on the vertical aspect of our triangle. And once again, we would need to find our hypotenuse, or the longest side. So 6 squared is 36. 5 squared is 25. And when we add those two together, we get 61, which once again, great work, Mr. Cartwright. 61 is not a perfect square. So C is just going to equal the square root of 61. So the distance between the points -3, 1 and 2, 7 is the square root of 61. Hopefully that all made sense. If it didn't, please return to the live classroom at this point with your questions. Thank you very much, and I'll see you in a sec.